in case you don't know how to do this, here are the directions on how to balance equations. Thanks for watching. I'll see you next video. Today we're going to be learning about balancing equations. So in order to do this, we have to first put one of each molecule on the side. Now we have to count them up, and on this side we have 2 hydrogen and 2 oxygen. The hydrogen is the gray and the oxygen is the red. Now on this side, since we have one of each, we're going to put, we have 2 hydrogen and 3 oxygen. Now we have to figure out how to balance this so that there's an even number of all the molecules on each side. So let's add another one of these up here. This gives us with now not just 2 of each, but with 4 of each. And it's still not balanced. So what we need to do is maybe we should add 1 H2O to the mix. This gives us 4 hydrogen and 4 oxygen. Now we see that we have 4 on each side of everything, so it's mixed. We can put 2 here because we have 2 H2O2, 2 here because 2 H2O, and 1 here because we only have 1 O2. In this scenario, we need to start with 1 of each again. And now we see that we have 1 oxygen and 2 hydrogen. So if we go to this side, we see we have 2 hydrogen and 2 oxygen. Once again, not equal. So we have to figure out how to make it equal. Well, let's add another H2O. This now gives us 2 oxygen and 4 hydrogen. If we do this, this is still not mixed, or even. And but we see that the oxygen is even. So we don't need to add any more oxygen molecules. We can just write a 1 right here. And if we add one more H2, we'll have 4 hydrogen. And that makes it mixed. So we'll have 2 H2O, 2 H2, and 1 O2. Now this example is a little more complicated. Once again, we start with 1 of each, but this time we have 2 molecules on each side, not just 1 molecule on one side and 2 molecules on another. So now let's count it up. C will be gray, so we have 1 gray, or carbon. Hydrogen will be blue, we have 4 hydrogen, and oxygen will be red, so we have 2 oxygen. Now on the other side, if we count it up, we have 1 carbon, 1 carbon, we have 2 hydrogen, and we have 3 oxygen. Now this isn't mixed, this isn't equal, so what we can do is that we see that the oxygens are not mixed. We can add another H2O. We can add another H2O and add another O2 so that both sides have 4 oxygen. Now that the oxygen is equal, we'll leave that there. Now we can work on the hydrogen. The hydrogen is also 4 because we put another H2O down there, so that's equal. And the carbons were always equal. So we have 1, 4, 4 on each side. So for the CH4, we have 1. For the O2, we have 2. For the CO2, we have 1. And for the H2O, we have 2. This example here is probably going to be the most complex one, just because of the C3H8. Once again, we add 1 of each. And now we count them up. Carbon will be black, we have 3. Hydrogen will be white, 8. Oxygen will be red, so we'll have 2. On this side, for carbon we have 1. For hydrogen, we have 2. For oxygen, we have 3. Once again, nothing is mixed on this page. Everything's mixed. So we can make the oxygens even by adding 1 more H2O and adding a second O2, which makes the oxygen now 4 on each side. But this messes up the hydrogen, which is going to be now 4 instead of 2, and that's still not even. So what we can do is we can add 2 more CO2s in order to mix up the carbons, so that way we have 3 on each side. But that changes the oxygen, which now gives us 1, 2, 3, 4, 5, 6, 7, 8 on each side. We can make it even with oxygen again by adding 2 more O2s, so that this side also has 8. Now what we need to do is make sure the hydrogens. In order to do that, we're going to once again have to use some H2Os. And now we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogen. Everything is even except now oxygen. Because now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can once again make this even by adding 1 more actually. 1 more thing. So now we have 10 oxygen, 8 hydrogen, and 3 carbon. That's kind of how many we used. We used 1 C3H8, 5 O2s, 3 CO2s, and 4 H2Os.